Okay, so this is Chapter 8, Part 2. Last time, so Chapter 8 is about bivariate correlation, and last time we were talking about some data that we had discussed before, specifically about information that I collected from a previous class. So last time we talked about the fake data, which we mentioned here. So if you look up here, this is the fake data. Let's get the same data now, but it's actually the real data. And I'm going to do this in RStudio Cloud. So what we'll need to do first is make sure that we upload the correct file. So I'm going to get this from a previous semester. All right, so I clicked on the right file to upload, pushed OK. And now I go to import dataset, and this is an Excel dataset. So it is the correlation data with grades. Let's go ahead and import this. And when we do this, you will see that it's going to look a lot like some other data that we've had in the past. So let me get rid of this for just a second. I have an extroversion scale. So a few items that were about extroversion was a scale, a loneliness scale, the number of texts that you sent in the last 24 hours, your relationship status, whether you're in a relationship or single, and your first exam score. I also have their other scores from the other assignments, but this is the exam score, highest 100% being 75 points. Okay, so what we're going to do now is we're going to actually run some of the data, but before we do that, we need to ask some questions. Number one, if I want to know whether people who are in a relationship did better on exam 1, what kind of statistic will I run? People who are in a relationship status is a categorical variable. You are either single or in a relationship. That categorical variable has 2 levels, single or in a relationship. Those are the 2 levels, that's it. You don't have any other levels, okay? So we got a categorical variable with 2 levels correlated with your exam score. The exam score is continuous because at least the intervals are the same, right? So it's a continuous data. So we've got a categorical with 2 variables, continuous data, that is going to be a t-test. Whereas if I want to know if people who are more extroverted did better on the first exam, extroversion, because extroversion is a scale, we're going to get continuous data. And exam 1 score is continuous as well, continuous with continuous. Now, before we go and do this, let's remember, is this kind of study a correlational study or is it an experimental study? This is a correlational study. Even the t-test is a correlational study because we did not manipulate the relationship status. We didn't randomly assign people to be in a relationship or to be single, right? We just measured whether they are in a relationship or single. So that's what makes this a correlational study. All right, let's go ahead and get the data. So remember, we need to attach. So I'm down here in the console. I'll attach the data that we just did. This is called correlational with grades. All right, let's run that t-test first. Okay, so t.test. Now, a t-test assumes that one variable is going to be the outcome variable. And in a t-test, that outcome variable has to be the continuous variable. Remember, we wanted to see whether or not your relationship status predicts your exam score. So we put the dependent variable, the outcome variable, first, and that's exam 1. Okay. Then we want it separated by the 2 categories. In that case, that's relationship. Now, we also need to, after we put a comma here, we need to give it one more piece of information. var.equal equals true, because we want a student's t-test, not a different kind of t-test. Anyway, you don't care, but we want the variance to be true. All right, so here's what we have. I want you to look at this data and tell me whether or not I should reject or fail to reject the null hypothesis. I should fail to reject the null hypothesis. But wait a minute, you say, look, here is the mean exam score for people in a relationship. It's 63.9. That's more than 62.9. They did a full point better, right? Well, this statistic doesn't just look at the means. It looks also at what's going on in terms of the variance of what's happening. So this t-test right here says, you know what? There's a difference between those groups. Yeah, there is a difference. But this p-value is the probability of getting that t, that 0.45612, if there is no difference between people in a relationship and people who are single in terms of their exam score. So this p-value is saying there's basically a 65% chance that we would get this result if the null hypothesis is actually true, if there's no effect of your relationship status on being single. And what that means is that normally the standard is at least 0.05, right? An alpha of 0.05. In which case, this is much greater than 0.05. We have to fail to reject the null hypothesis. All right. Let's go ahead and look at the other test that we were talking about, and that is the test of whether or not people who are extroverted, higher extroversion, leads to a higher exam score. Instead of a t-test, we are going to use what statistic? We are going to use a Pearson's R, right? A Pearson's product moment correlation coefficient. That's Pearson's R, lowercase r. So core.test is how you get that in RStudio. And this doesn't matter which one goes first because they're both continuous, so it doesn't matter at all. So extroversion, comma, exam 1. All right. That's all you have to do to get the correct data out of this one. All right. Am I going to reject or fail to reject the null hypothesis? I am, again, going to fail to reject the null hypothesis. Now, you might say, well, what are you talking about? Remember, we're looking at the p-value. What is the probability of getting the statistic when the null hypothesis is true? The statistic that we actually get, the correlation is right here. It's the negative 0.14. This says there is a relationship. It's saying that as extroversion goes up, exam scores go down. That is what it's saying, right? That is what it says. But the probability of getting that value by chance, that is, getting that value when the null hypothesis is true, is about 27%. And that is too high, right? That's too high for our standards. Our standard is 0.05, so therefore we have to fail to reject the null hypothesis. All right, let's do one more example. If I want to know if people who are lonely send more texts, what kind of test am I going to run? Let me show it to you one more time. Loneliness is measured in a scale, and texts is just the number of texts you sent in the last 24 hours. Are people who are more lonely more likely to send more texts? What test am I using? All right, this is also Pearson's R because loneliness, any scale is going to give you continuous data. And texts, 0 means 0, right? And one text is, the same interval as the other, so that's continuous data because it's probably ratio. So in this case, we're going to do a Pearson's R. We do a core.test. We were looking at loneliness, comma, and text. Okay, do I reject or fail to reject the null hypothesis? I, again, am going to fail to reject that null hypothesis, right? Because in this particular case, the p-value is greater than 0.05, right? The probability of us getting this relationship, meaning Pearson's R, 0.096, is the probability is too high when the null hypothesis is true. Let's do one last one on this, and then we'll look at some other examples. I think that people who are in a relationship are less lonely than people who are single. What test am I going to use? Now remember, relationship status, that is categorical, and there's two levels, single or in a relationship. And so I'm going to use a t-test because loneliness is continuous. So I'm going to t.test. I put the dependent variable first, right? The outcome variable is loneliness in this case, loneliness. And then I put a little tilde right there. And relationship is the predictor in this case, comma var dot equals true. Okay, you tell me, are we going to say that people who are in a relationship are less lonely than people who are not in a relationship? So first of all, you should take a look at this. This is real data, by the way. This is the mean amount of loneliness for people who are in a relationship. This is the mean amount of loneliness for people who are single. So actually, people who are in a relationship are saying that they're lonelier in the mean. However, the probability of getting that when the null hypothesis is true is about 72%. So again, we're going to fail to reject the null hypothesis. None of these hypotheses that we came up with have been supported. The null hypothesis we have to fail to reject every time. Let's take a look at this in another example. So on an exam, for example, I might give you just the output. For example, this right here. Whoop, right here. This is what kind of test? This is a Pearson's R. But wait a minute, you say. It says T right there. It says t-test. So that's not a Pearson's R, because look, it says right here, it says T. Let's see if I can get it to mark. No, I'm not going to be able to. It says T equals negative 1.69. Well, what happens when you're testing the actual p-value is that statistically you have to change the correlation, the Pearson's R, which is at the very bottom, the negative 0.2099036, right there. Okay, that is, this is the correlation right here. Whoops, go back. Okay, so right here, that's the correlation coefficient. This T up here, that T has been transformed. We've transformed the R into a T so that we could check the p-value. I know that's confusing, but when it says Pearson's product moment correlation, you believe it. And if it's got COR, that stands for correlation, that's the actual statistic that we care about, and this is the p-value for that correlation. If we have a Pearson's R like this, what kind of claim is being made? Frequency, association, or causality? When you've got a Pearson's R, you're talking about an association claim. Correlational studies give you association claims. All right, now let's go to the next one. This is a t-test, just like we did before. Okay, we've got the means of the two groups right here, right there, right here. Okay, this p-value is the p-value of this t statistic right here. Now, when you see a t-test, what kind of claim could be made if you see a t-test? If you see a t-test, it can be either an association claim or a causal claim. It depends on how they set up the study. It depends on if those categories of in a relationship and single are being measured or manipulated. If they're being measured, then you've got an association claim. Measure and measure, that's a correlational study, which gives us an association claim. If you manipulate, which means you randomly assign half the people to be in a relationship and the other half to be single, then that's a manipulation, and you can have a causal claim. But it depends. Just because you see a t-test doesn't mean that you know which kind of claim is being made, whether it's a correlational study or an experiment. This last one was some of the other data that we saw before, and so we don't need to look at this too much, except that let's say that I want to look at this relationship. So let's say that I've got the data here, and my hypothesis, let's see if I can get my pen to work. I don't know that I can. Whoops, go back. Let's see if I can mark it. Here we go. So let's say that my hypothesis is that I think that, what do I have here? The number of texts is going to affect your exam score. Text. I'm doing this with the texts and exam. Let's see if I can get this to work. Oh, there we go. That they are related, right? So this is my idea, that the more you text, the lower your exam score, let's say, right? This would be a bivariate correlation. We count the number of texts, we count the number of exam scores. However, let's say that you think that there might be something else going on. You think that the number of texts you send might affect your exam score, but it depends. Texts lead to lower exam scores generally. That's what these two would say. But let's say that we think that there's another variable in here. That other variable is your relationship status. And you think that that texts lead to lower exam scores, but only if you are single. If you are in a relationship, then more texting leads to more social support, and so you're more likely to do better on your exam. This is no longer a bivariate relationship. This is a moderated relationship. The relationship status is moderating the relationship between text and exams. We'll get into this a little bit more later on, right? But this would be a moderated relationship. Another way that third variables are used in studies is if you say, hey, what if I think that instead of that being the relationship this way, I think that what happens is people who text more are more likely to be in a relationship, and people who are in a relationship do better on exams. That's no longer a moderated relationship. That's what's called a mediated relationship. And that's something we'll discuss more in Chapter 9. I know that in Chapter 8, though, they discussed what a moderated relationship is. The reason why you care about a moderated relationship is because you will need to know when to use a moderated design versus a mediated design, when to use the correct statistic to test a moderated design versus a mediated design. And that's coming up in some later chapters. All right, let's go ahead and end there.